This lesson will teach me to order the side lengths of a triangle when given the angles, order the angles of a triangle when given the sides, and apply the triangle inequality theorem. There are lots of words here, so kind of look at them for a second and write down what you need. We can use what is given about a triangle to order its lengths and its sides. So we have a couple of options. First option, if you are given the lengths of the sides, then you can order the size of the angles. Or vice versa. If you are given the angle sizes, then you can order the side lengths. Okay, so how can we order them? It says if two side lengths of a triangle are not congruent, then the larger angle lies opposite the longer side. Look at this one down here. If two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. These are pretty much just the opposite each other. This one starts with angles and says that you can talk about sides. This one talks about sides and then goes on to angles. So it's saying, let me pull up my animation here, and I'm down here with this note. If you find the longest side is this 8.5. Oops, is this 8.56. Opposite from it is 9.42. It's the largest of the angles. Look for the smallest side, 5.3. Now find the smallest angle. It's the 37.1. These are opposite. So we can order the side lengths. So if I wanted to know what side was the smallest, all I'd need to do is look at the angle. If I wanted to know what angle was the smallest, all I'd have to do is look at the sides. And vice versa. If I wanted to know angles, sides, angles. So let me get back in here to SMART. Let me give you a couple of examples here. This slide I threw in, my students did this last year. It says, just gives you the definitions of sides being opposite angles. So it says the leg of a triangle that is not connected to the vertex. Notice we have this white circle right here, that vertex. The purple is opposite, meaning across. Side opposite an angle is the side of a shape opposite or across from a certain point. Across. Students always seem to goof that up with this one. Let's look at a couple of examples. It says list the angles of triangle ABC from smallest to largest. So in this particular triangle over here, I want to talk about angles being the smallest all the way to the largest, but all I was given was side lengths. So if you want the smallest angle, find the smallest side. The smallest side is 18, so that means the smallest angle is angle A. If you want the largest angle, then that means you're really looking for the longest side. And so the one in the middle must be angle C. So the smallest angle is across from the smallest side. And if we were able to figure out that angle measurement, it is going to be smaller than, say, angle B. Visually, they are smaller than, A is smaller than angle B. Letter B says list the sides of triangle XYZ from shortest to longest. So now here we're talking about side lengths. Whoops. And we want to do side lengths from short to long. But all they gave us were angles, and only two angles at that. We know that triangles add up to 180 degrees. 60 and 40 is already 100, so this angle must be 80. If I want the shortest side, it needs to be across from the smallest angle. 40 is the smallest angle, so if I go across from that, that means side YZ is the shortest side. The longest side is going to be opposite the longest angle. Well, it looks to me out of 40, 60, and 80 that 80 is the largest angle. So that means across from it is the longest side. So the one that must be like short, medium, long would be the other one. So X. y. In triangle PQR, it says angle Q is a right angle. So PRQ, Q is a right angle. Which side is the longest? Well, in a right angle, we know that the longest side is the hypotenuse. But this isn't really asking for that. It's asking which side is the longest. Well, we know it has to be the one opposite. That's something that we've talked about before, but it also has to do with this theorem, saying that the longest side is across from the largest angle. All right, here's another question for you. Can any three segments form a triangle? And the answer is no. Think about taking a really long piece of decking, a meter stick, and your pencil. There's no way that you'd be able to form a triangle, a really long piece of decking, a meter stick, and your pencil wouldn't actually bridge the gap to make you a triangle. So no, not any three segment lengths can form a triangle. So how do you know which ones can and which ones can't? We have something called the triangle inequality theorem, and you'll need to fill this in up above. It says the sum of the lengths of any two sides of a triangle is greater than the length of a third side. So in order for these triangles, for these three pieces to actually connect and make a triangle, two of them added up has to be bigger than the third. So if we think about two of them adding up, if we were to add up, if we were to check the, says xy and yz, it would have to be bigger than, those lengths would have to be bigger than the third. And look at them. Those two green lengths are visually longer than that blue one. Let's check a couple more. YZ and ZX is visually longer than the length of x to y. So there's your theorem. Make sure you get it jotted down. And let me show you an animation. And in this animation, we're looking at this red box called the triangle inequality theorem. Pretty much just sums up what I had. These are the inequalities for triangle ABC. The one in your example had triangle XYZ. And then it goes down here and even adds things up for you. So it says take the 6.7, the 8.83, those two sides added up have to be bigger than the 5.3. The 6.67 and the 5.3 have to be bigger than the 8.83. And the 8.83 added to the 5.3 have to be bigger than the 6.7. This is going to hold true for any triangle. Teeny, teeny, tiny. Look at all three of these lengths. Those two added up are bigger. Those two added up are bigger. Those two added up are bigger. And grab your calculator and add up those side lengths. Even if we got to something pretty big, 18 and 19 is bigger than 5. 18 and 5 is bigger than 19. 19 and 5 is bigger than 18. So at any point, if you're given three side lengths, like the example that I mentioned at the beginning, a piece of long, like 2x4 decking, a meter stick, and your pencil, if you were given these three lengths, I bet the pencil length and the meter stick length aren't going to give enough to actually add up to the length of whatever piece of decking you have. Think about a really long piece of wood, meaning that there is a gap, so you're not going to have a triangle. So let's look at a couple of examples. All right, so for our example, if I have a piece of wood, a board that's 3 inches, one that's 4 inches, and one that's 5 inches, I want to know that if I were to nail these together, would they actually make a triangle? So take two of them, 3 plus 4, add them up. It needs to be bigger than 5. Is it? Yeah, 7 is bigger than 5. If I were to do 4 plus 5, is it bigger than 3? Yes. And then what other combination haven't I added? I did 3 and 4, 4 and 5, 3 and 5. That gives me 8. Is that bigger than the other length? Yes. So will these three form a triangle? Yes, they will. All right, let's try it with these. If I had a board that was 5 inches, a board that was 10 inches, and a board that was 15 inches, would those form a triangle? Well, let's try it. If I were to add up two of them, 5 plus 10 would have to be greater than 15. 5 plus 15 would have to be greater than 10. And the other combo would be 10 and 15 would have to be greater than 5. Well, that's definitely bigger than 5. 5 and 15 is 20. That's bigger than 10. But look at this one. 5 and 10, it says greater than. It doesn't say greater than or equal to. So no, that's not true, meaning that if you were to take something that's 15 inches, something that's 10 inches, and something that's 5 inches, you're going to have a gap, meaning that these aren't going to form a triangle. All right, couple more problems. A triangle has a side lengths of 8 and 10. Describe the lengths of the third side. I don't know the length of the third side, so I'm going to go ahead and call it x, and I'm going to set up these three inequalities. If I do 8 and 10, whatever 8 and 10 centimeters, it's going to have to be bigger than the third side. If I look at 8 and the third side, it has to be bigger than 10. And if I do 10 and the third side, it's going to have to be bigger than 8. So calculate what x is going to be. 8 and 10 is 18. Minus 8 minus 8. X has to be bigger than 2. And this, you're always going to get one that doesn't seem to make sense. It's because of the inequality. Whoops, 2. So don't really worry about it. Look at the two that do make sense. This is telling you that x has to be bigger than 2, and at the same time, x has to be less than 18. So if you were to have a blank, an 8, and a 10, you could fill that blank with any value as long as it's larger than 2, so 2.1, 2.2, 2.3, 5, 10, 11, 12, all of those, and anything less than 18. So 17.99, 17, all the way down. So this can be any value as long as it's larger than 2 and smaller than 18. Go ahead and try this one. Same thing. Find the lengths of the third side. I'm going to call the third side x, and I'm going to set up my triangle inequalities. Go ahead and take a peek at my answer. So I set up that 2 and 12 have to be bigger than the unknown third, that 2 and that third side have to be bigger than 12, and 12 and the third side have to be bigger than 2. This was the one that when I calculated it didn't make any sense, so don't worry about it. But look at the two that we do have. X has to be between 10 and 14. So again, if we were to look at the three lengths of the sides of this triangle, as long as this value is somewhere bigger than 10, 10.1, 10.2, and somewhere smaller than 14, 13.9, 13.12, whatever, then you would have a triangle. And that concludes the lesson. Thanks.